Hello everybody. Cristina Lumbreras from EENA speaking. Welcome to all of you. We have all here all our speakers ready for this webinar. We will still wait 5 more minutes to give the opportunity to everybody to connect. And I hope you will be interested. I think we have some echo from
Cristina. It's better to have echo other than ego.
Yes, that's true. The worst is to have ego and echo. Double ego. Okay, so if also from the panelists, the people and the speakers who are going to present, if you are not speaking, please mute your microphone. I think this way we will be, I think we will listen to everybody better. So I see people are still connecting. There are still people connecting. We will start in 2 minutes. I see still people connecting. Let's give 1 more minute and 1 more minute and we will start, because there are still people coming. Well, it's really 2 p.m. 00, so let's give them 1 more minute before starting. Okay, I think we can start now, if that's okay for all speakers. I know you are already ready. So I'm Cristina Lumbreras. I work for EENA. I really welcome everybody to this webinar. It's the webinar about the results of the NG112 project EENA organized. We launched it last year at the EENA conference. The idea was to share with you all the results at this year's EENA conference, but as you know, of course, due to the COVID-19 crisis, we couldn't do it now. So we decided to share with you the information about the project earlier through the reports and 2 webinars. All the reports have been already published, and we are here in the second webinar. So on this, in this project, we had 3 consortia working on the implementation and testing the implementation of NG112 in their countries. We had a first consortium who presented its work some days before, the Celeste project that was Italy, Denmark, and Austria. And today we have 2 consortia that who will present us all the work that they have done, that it's really interesting. We have the Turkish consortium that is here with us, and also the Croatian consortium that also will present afterwards. So I first want to congratulate the 2 consortia because they have done really very interesting and good work. Thank you very much for all your efforts. They will present now, and then you will have the time to ask questions. So there will be 2 presentations. First, the Turkish consortium, then will be a time for Q&A for your part from the assistants and for the participants, and then we will go to the second presentation, and there will be again time for questions and answers. You will have, if you want to make a question, you can do it, you can raise your hand, and then I will unmute your microphone so that you can speak and make your question. Or if you prefer, you can just write it. And I will go directly already to the Turkish presentation, because I want really to give the floor as soon as possible, not to lose more time.
Hello, everybody.
Can you see the slides?
Yes, I can see the slides. Perfect.
Okay.
Thank you. Firstly, I would like to thank to Cristina and EENA team for supporting us in the context of Next Generation 112. EENA has a very important role for working on standards, creating standards. In this project, we had the chance of testing NG112 according to technical standards of EENA by the help of Cristina. And next slide, please. And we are I am from Emergency Ambulance Physicians Association. I worked many years in ambulance, and I am a physician. And this AAHD is a medical end user and NGO. And my colleague from Ministry of Health is Ahmet. And he can say maybe hello. And here, Ministry of Health provides coordination with the Ministry of Interior for this project. Ministry of Health has a medical PSAP and EMS organization, and other partners, Eygü Aksaray from Armacom Information Technologies. It's a CAT provider, very big firm, and provides NG112 architecture components. And Turkcell is not here, but a telecommunication provider of Armacom. And Havelsan, Dr. Tolga Sönmez. Havelsan is also from security domain, big industry, and they are producing device, NG112 architecture components, and CAT provider. Next slide, please. You can see here NG112 project plan, and we firstly developed the plan, and we test emergency audio and video call, and then real-time text call testing. Then we test intelligent home speaker testings, and we conclude the report and release the report by EENA. Next slide, please. Here you can see a picture from our NGO. AAHD has been established in 2004. All the members are physicians working ambulance or command centers, and we are involved EU projects since 2008, mainly from security domain. So we had to learn this next generation technologies from our projects. Since 2015, we are organizing next generation technologies in emergency services symposiums in Turkey to promote this idea and this terminology in first responders, because it is a completely different terminology. And we prepared EMS ecosystem for our ongoing project I Procure Security. Here you can see the EMS ecosystem figure. It starts with the emergency call, or we can say emergency communication now, from the scene, incident site, by the patient or bystander. Then the response phase starts, then transferring the patient or casualty to the right suitable hospital. As you can see in this picture, in every step, communication system is critical and really helps to save lives. Next slide, please. And in Turkey, for many years, we have this previous old system, and we had level 1 sub-services in Turkey, which means every emergency response organization have their own command center and number. Then in 2015, 112 single number project started in Antalya as a pilot. And now many cities we have this system, and it is proceeding. And next slide, please. Now I will give the floor to my colleague Ahmet.
Thanks, Zeynep. First of all, I want to express that in this pandemic, I share the pain of those who lost their lives. There was no such pandemic or threat when we heard about this project. At this stage, our main goal was only to improve the call center services and quality. We focused more tightly with the project call opened by EENA. When we look at what has been achieved at this stage when we have reached today, it seems that a preparation has been made for today. We hope that the project results will be put into service as soon as possible by the call centers and will contribute to humanity in our country and in the world. In our country, pre-hospital emergency health services have been providing services through call centers since 1987. The task of regulating emergency health services belongs to the General Directorate of Emergency Health Service of the Ministry of Health. In this context, 5,400 ambulance, 2,800 emergency cruise stations, 17 helicopter ambulance, 3 aircraft ambulance, and 4 sea ambulances serves all over the country except special ambulance. Next slide, please. Joint general call centers have been structured as the Ministry of Interior, General Directorate of Provincial Administration and Emergency Call Center projects since 2008, and all emergency calls are directed to a single centers and distributed to service groups. Currently, 45 out 81 provinces have been opened to date, and others are expected to be completed within 1 or 2 years. 112 barrier-free project carried out by the Ministry of Interior to solve the problem of hearing impaired and foreign language applications, and in vehicle emergency call system project were completed and put into service. Thanks for watching to me. After that, we will continue listen from the Armacom team.
Hello, thank you. Here, as Armacom, we are starting on 112 call management systems for 18 years, since 2002. And here, when we heard about the project from Mr. Türkdemir and Ms. Sofoğlu, we really felt happy to be able to work on such a project. And here, as Turkey Consortium, we started to work on the 4 use cases proposed by the EENA. The emergency text messaging use case, video call, emergency video call use case, emergency audio call use case, and the emergency call from intelligent home speakers. Here, as Armacom, we have studied the first 3, and I am going to talk about on them, and then I will give the word to Mr. Sönmez. Can I take the next slide, please? Sorry, the next one also. Yes. Here there is a short summary of what we have done, the development and testing phases. The development was made on desktop applications and also on mobile applications. I can start with text messaging use case, if I can take the next slide. Here you see the architecture for the text messaging system. In this, by implementing this use case, we are aiming to give chance to people to request help with disabilities, and also in such cases sometimes earthquakes people cannot make a standard phone call and cannot reach to the 112 centers. And in this architecture, the process starts with the application from the smartphone. The location information of the caller is passed through the web services, and a boundary control function takes the request. And after that, the ECFR takes the finds the appropriate public sorry, I'm a bit excited. Public safety answering point, and the most suitable call taker is notified about the messaging request. As soon as the call taker accepts the request, the communication session has established, and the communication starts. Here and in this architecture, the procedure is as if a phone call between a call taker and the caller. The call taker does not receive any other notification about a phone call or any other type of call until the messaging finishes. I can take the next slide if it's okay here. Here the screenshots are taken from the test procedures shown on the screen. The mobile application on the left and the desktop application on the right. During the communication, the call taker also sees the exact location of the caller as well as the chat screen. I can take if there is no question about this one at the moment, I can continue to the audio and video case. Okay, here in the emergency audio and video call system, the architecture is the same for our point of view, since there is only a voice passing, or a video is also going with the voice. In this case, the STAN servers are used to start the request. The request is started from smartphone, and the STAN server takes the SIP request part. Again, the exact location of the caller is transmitted to the system. The boundary control function decides which PSAP will answer the request, and the request passes to that PSAP. There again, the most available call taker receives the call request, and as soon as the call taker accepts the request, a SIP session starts between the caller and the call taker or the dispatcher, according to the scenario, and the communication starts, and the media transfer starts between them after the session has established. We can pass to the next slide again. Here is again a sample screenshots about the tests. This is the screenshots from video call. We can go on. Here, what the difficulties we have experienced during the tests and implementation. After we start the tests, we realized that the video quality improvement is necessary for the video call use case, because the desktop uses the desktop application uses a video application that needs more bandwidth, and there's a smartphone at the other side, and for that reason we had to make some changes on the quality improvement and reducing the bandwidth between the communication. Also, we realized that the indication of the exact location of the caller should be done to the call taker, because sometimes the user thinks that the location is not the exact location. He feels that the caller is somewhere around the point we are showing. And then we saw that the writing in the text messaging case is sometimes be difficult. For example, the people with the ability to write sentences in slowly writing people. For example, me. It took for about 4 minutes to tell that I am under a building during an earthquake. And we decided to make a predefined sentence offering algorithms for both sides in this case, because sometimes the call taker needs to write every single sentence once again for each caller. And next slide, please. In the future work plan, we have to we decided to improve our the problems that we faced with. Again, the implementation of predefined smart sentences should be added to the system. Also, the video call feature. I forgot to tell that. We realized that during the tests that sometimes a person making a video call and asking for an ambulance, then the call taker or dispatcher should return back to the caller. At this moment, the system does not have any video callback functionality in the system. So we have to implement that functionality also, because at this moment the system receives the text messaging, receives the video or audio call, but there is no return back from the same way. Also, the personal health data taken from the user, or maybe taken from the local from the Ministry of Health system. Maybe the basic health information also should be transferred to the call taker in order to take the special actions for the case. We are planning to implement this feature also. That's all for my side, and I'm going to give the word to Mr. Sönmez.
Thank you, Ege. First, let me introduce myself. My name is Tolga Sönmez, and I am working for Havelsan, and we are a large industrial company in Ankara. And we basically work in situational awareness and security projects. And here in this project, we have gladly developed this command recognition system, which will be a emulation of this intelligent home speaker systems. So basically, we have a microphone and a local processing power, and we continuously listen to the environment to detect some commands. And these commands, in our case, for this NG112 case, is basically emergency words like help, ambulance, fire, things like that. And we have used a microphone. It is just a general microphone, omnidirectional microphone. And if we use an intelligent home speaker for this system, basically they have a microphone array, not just a single microphone, but a microphone array. So you can also have some high directivity in these devices. And we after we detect this information, the commands, then we provide this information to the internet, and basically from that point, Armocom has also provided us the basic functionality of NG112 long-term definition architecture, and we provide the basic emergency call data to this system. Next, please. So this graph basically gives more detail about the NG112 long-term definition. So it's very similar to what Egu has described about this text messaging or other functionalities. So in the edge, we provide a commercial microphone and a local PC for command recognition. And we continuously listen to the environment. And if we detect the special keywords, then we provide this to the border control function. And through the system, we dispatch to the PSAPs, to the related PSAPs, this information. Of course, we also add some relevant information like location and also some past data maybe to the final PSAPs. Next, please. So our system has basically two functionalities, two phases. In the first phase, there's a training phase. So we have to recognize not just the command, but also the speaker, because we only want the commands coming from an authorized speaker. So in the case of emergency, for example, we don't want a child to make unreal calls. So we have to authorize the speaker. And so we are looking all the time for both the commands, for the special keywords and for the speaker. And we first train the system with the specific person and with the specific command words. We make a filtering and we use null frequency substral coefficients. So it's a very basic algorithm in speech cognition. And we train a hidden Markov models for each speaker and command. And we have developed some routines for this algorithm. And we, of course, we record these generated models into a file. In the runtime phase, as I said, we are continuously listening to the environment with a microphone, and we convert this data to some digital data, and we do some audio detection. So if the noise in the environment is above a threshold, then we further process it to detect these special keywords, and we pass it to the MFCC algorithm, and we pass it to the hidden Markov model for each speaker and command, and we calculate a score for each person and with the specific score, and we present it. We decide about the final speaker and the command according to the score, and after we make this decision, we relay this information to the NG112 system. Next, please. So we also developed a user interface. So it has the basic functionalities. The first one, as you can see on the left, is the real-time speech recognition. So it is the really runtime application. And for the configuration, we have to take some speaker command inputs, and we have to record them separately. And we also have some testing functionalities. And of course, we can reset the training data, delete a speaker, and we have developed such functionalities with a user interface in a console application. Next, please. So what do we have? We require a microphone. It could be wired or wireless, and a processing unit. And we have, for the processing unit, we have tried a local PC, and also we have tried a Raspberry Pi actually for the embedded computer. And in all these kind of this hardware, our system has worked. And in the training mode, we first record of course, the speakers, and we make the speaker to repeat the special keywords 5 or 10 times so that we can detect the discrepancies. And our basic commands were ambulance, police, fire, help, and such things. And we automatically generate a hidden Markov model for each of these recordings. And in the runtime mode, of course, we continuously listen to the environment and we compare it with the authorized stickers and authorized keywords. Okay, next please. And in the tests, we have tried actually more than 20 people for the real-time tests, and our real-time comment detection accuracy was above 95%. Simultaneous real-time speaker identification is again above 95%. And we have tried up to now up to 20 comments. So we are not doing a total speech recognition, but just we are detecting the special keywords. And we have used the system with 3 to 5 speaker detection at the same time. So you can think of it as an average household in a given home. And we do speaker authorization. And we don't have a very much computation time actually. So we have near real-time command and speaker recognition. Of course, we have there could be some network latency in the system. We run our system in both Linux and Windows operating systems. And it's also very cost efficient right now. We just need only hardware and a local PC. And even this local PC could be a Raspberry Pi actually. So it's a very low-end hardware. And of course, we can change the system with this commercial intelligent home speakers. Yeah, and in this case, we have to use their interfaces that is provided for the third-party users. Of course, they have different requirements and regulations, so we have to just adapt our system to these requirements. And of course, there is some GPDR issues also because we are continuously listening to an environment, and we can record at least what is said in that requirement. So actually, it has to be really regulated very carefully. So what we think that we should keep the processing in the edge system and only send just the keywords and the authorized person to the NG112 system, so that we can provide the privacy of the user. I think that's all. Next, please. Yeah, so we are done. Thank you very much.
Thank you. Thank you very much for this very interesting presentation. And again, congratulations for all the work that you have done. I will now ask the participants for questions. If you can raise your hand or you can write questions. If I see one raised hand from Daniel Rata. Daniel, I will unmute you so that you can speak.
Hello, I'm Daniel from 112 Romania. I was wondering what kind of codecs have you used for the video calls? Did you hear me?
I forgot to unmute. Sorry. Here we have used commercial products for the mobile one for especially we have implemented it for Android first, but iOS type will also be ready, and we used mostly used codecs for them, and also for the desktop case also the known products were used, but tried different standards, and now exactly we developed our own code for the transfer at the final stage.
Daniel, do you want to add any other question?
No, that's all for me. Thanks. Thank you so much.
Okay, I see another hands. I see Andrew Richards, that you have raised your hand. I will unmute your microphone, Andrew. Andrew Richards. We cannot hear you. Okay. We have also Dimitri Ershov. I will unmute you. Hello.
Hello. Hello, I'm Dimitri Yershov. I'm head of Salute project. We create and develop a messenger Salute. This is messenger for drivers, which works like a real walkie-talkie. We can send push-to-talk message, short voice message or text messages to everyone who is nearby or to friends or by car license plate. We can use this application to inform volunteers who is nearby to place of road accident, for example, the victims. And I'd like to discuss about possibilities to use Messenger to inform volunteers who is stay near the place of incident, because in these cases we can organize emergency help timely, more quickly, while until waiting because professional medical command will arrive.
Do you have any concrete question for any of the?
I'd like to discuss about this possibility in new generation of 112 system with someone. If I send my email, can we discuss about these options?
Yes, of course.
Okay, thank you.
Yes,
Okay,
Dimitri.
then. Yes. Go ahead, Zeynep, please.
Yes, please send your email. You can find our emails in the Turkish report.
Okay, Christina, I send you my email. Can you connect me with Jennifer?
Okay, we will keep this offline after the webinar. This is okay. I will give the floor to another person who has who have raised the hands. I have here Gaurav G. I will unmute you.
Okay, thank you, Christina. First of all, thank you to everybody for spending the time here to explain your systems and give us a view into this. So, my name is Gaurav. I have two questions, and it's open to anybody who would like to answer. First of all, when you look at using some of these applications or any of these new, tools that you give to, whether it's your front officers, you give your members of public, or you give to your own emergency responders, how do you handle data privacy issues? For example, I saw one of your slides saying that, okay, health plans are shared then with a PSAP. So again, that's very personal information. That's PIP information. How are concerns about data privacy handled? That's one. My second question is, when you look at scaling things like your command recognition and your keywords, and when you want to scale it to a larger level, were you exploring the uses of any cloud-based services to actually do that rather than doing everything, on a PC as such? Because at some point of time, when you start getting more machine learning and all of that involved, then maybe you need to start using in maybe some kind of cloud services. So did you do that during your investigation? So these are my two questions, and anybody can answer, please.
Okay, so let me first answer your second question. Actually, of course, we can use cloud services. So, for example, Google has some services for this kind of services. But first of all, we don't want to, because of the privacy issues, we don't want to put all our data to the cloud. So we think that if we solve the most of the things in the edge systems, then there will be less privacy issues. Okay. So, and in our case, for example, we are not doing a total speech recognition system. So we don't have to understand everything the user has said. So we are only looking for the specific keywords. So that's why I think we have our edge, an algorithm that's running on the edge system is enough for us. It is necessary. It satisfies the necessary and sufficient condition for us. And of course, it will create less and less privacy issues as we do not share everything in the cloud, just the necessary information.
Okay, do you want to add anything more on this topic?
Can I answer the first question here? About the privacy of the patients. Of course, the personal health data should not be shared without his or her permission to the PSAP center or the call taker. But from the application, the caller can give permission to share, of course, some of his data. For example, he has a type 1 diabetes or has a cardiac problem. Maybe he wants to share that data with the emergency center so that the call taker or dispatcher decides to send a specialized crew to the location. For that reason, the data sharing may take advantage.
Okay, thank you. I see.
Also,
yes, please, Zeynep, go ahead.
thank you. Also, 112 command center can give post-dispatch instructions if they know the medical history.
Okay. Thank you. I don't see any other people raising their hands, or I don't see any question on the chat. So thank you very much. So yes, here I think there's a question. Okay, there's another question from Gaurav. How is location shared? Is it simple GPS?
No, the location of the caller is not only the GPS data, also, but also combined with the location taken from the service provider, and from the combination of the information, the location of the mobile phone is almost known exactly, and that data is being transferred from the system.
Okay, thank you. So I don't see any other questions or hands raised. So thank you very much for your presentation. Oh, wait, there's another question. Is the video, each time I say that there's no question, there's another one. Okay. Is the video from the call shared with the first responder to give them better situational awareness?
Sorry, can you repeat the question again?
Is the video from the call shared with the first responder to give them better situational awareness?
In fact, we didn't implement that part, but it's a good idea, I think, because of course it can help to the first responder. Thank you.
Okay. So now I think we close the time for questions. You can, of course, contact the presenters for further questions, or you can also send it to me and I will forward them the question. Thank you very much again, and I will share now the presentation from the Croatian consortium, and I will give you the floor as soon as you can see the presentation. Can you see the presentation?
Yes.
Okay. So the floor is yours.
Okay, hi. First, I would like, in behalf of Croatia, I'd like to thank EENA for opportunity to explore of newer technologies in context of emergency services. Can you next move to next slide, please? Main goal of our project is to test possibility of using already existing technologies to access 112 and other emergency services without need to have anything especially install preparation on caller side. And also a solution should be based on EENA NextGen 112 long-term definition standards. So to make emergency services fully reachable, not just via classical phone line or mobile phone, but also via internet, and to do so on a standardized way. Next slide, please. Our motivation for this approach is that we believe that people generally do not prepare for emergency beforehand. So it is not something that they need until they need it. So you generally don't plan for accident that you might have or for emergency service that you might need. So therefore, we wanted to explore possibilities of implement standardized NextGen 112 solution without the need to anything specially installed on caller side, so that the caller citizen can use what he already has in his pocket. All needed technology in principle exists already on smartphones, internet connection, standard-based browser that are video, audio capable. And it made sense for us to explore these possibilities. Next slide, please. We have three main use cases, which comes down to the same sets of technologies, but that covers wide area of needs. That is voice call, which would be, I think, primary methods to engage when there is no special need for video, which uses lesser bandwidth. Then it is a video call, of course, with voice. It is especially important for certain situations, not always, but when it is needed very much. And then it is a text emergency call for situation for deaf people or situation where caller does not want to be discovered or heard. Next slide, please, and I will let colleague from Civil Protectorate to.
The number 112 in the Republic of Croatia is
Sorry, we cannot hear you.
Hi, it seems that you might have accidentally muted yourselves.
Yes, we have a problem with unmuting. We could not read the message that
there's a big echo.
Okay.
Can you hear me now?
Yes, we can hear you. I believe there's an echo because both of you are in the same room, but both of you are also able to mute and unmute yourselves at any time. So now it seems to be working.
Yes. Is it all right now?
Yes, but there's like an echo.
Is it better now?
Yes, now it's perfect. Now it's perfect. I will share again my screen and we will be able to continue. These technical problems can happen, don't worry. Okay, I think this was the good slide and I will mute myself.
Yes, it's okay. So I will repeat from the beginning. The 112 number in the Republic of Croatia is managed by the Civil Protection Directorate, which organizationally belongs to the Ministry of the Interior. With the Ministry, Civil Protection Directorate is an administrative organization that prepares plans, manages, and coordinates civil protection operational forces in order to be able to guide the prevention and rescue missions in emergencies. 20 112 PSAPs called County 112 Centers, then 112 Sector and Civil Protection Operational Center form the Croatian 112 system, which is the core of civil protection information and communication system. 112 PSAPs do not only establish contact with the callers and emergency services, but in addition have a significant role in major accidents and disasters. When civil protection organizational forces and the population must be alerted or warned. The 112 sector is responsible for the efficient functioning of the 112 number, and Civil Protection Operational Center does not receive calls, 112 calls, but continuously monitors events reported to the number 112 and performs communication and coordination tasks at the national and international level. Please, next slide. So on this slide, the Croatian model, the Croatian model for 112 calls handling is shown. On this slide, the mutual connection of the PSAPs of the Croatian 112 system is shown. This organization ensures the flow of information from the local to higher levels and vice versa for each significant event. The 15 county 112 centers the red ones, are synchronized and networked to the main county 112 centers, the green ones on the slide. In those 15 112 PSAPs within the expertise of King ICT is implemented Sfera technical solution within the, with the corresponding hardware and software infrastructure. Please, next slide. On this slide, the Croatian model of 112 calls handling is shown. 112 calls are handled by an ERO independent PSAPs. This is the county 112 centers. The operator of 112 PSAP receives callers' location information, classifies the event, and decides which EROs should be contacted. Depends on situation, alerts also other rescue services as mountain rescue service, inspections, or any other civil protection operational forces. Dispatch of the intervention resources are done by EROs. Please, next slide. The 112 system in Croatia is currently able to provide required functionalities to emergency services, such as location information of a caller or SMS sender, network-based or AML, fast and automatic location visualization, SMS chat for people with disabilities, e-calls, and others. However, because of different needs of and possibilities of users, a very diverse range of communication services and devices, changes in the provision of network services, and continuing to adopt regulations as European Electronic Communication Code and the European Accessibility Code Act, there is more to do to make possible the access of all users to the 112 number under equal conditions, keeping up with the new technologies and user needs. Please, next slide. So in the Republic of Croatia, in the 112 system, we are taking the necessary changes at different areas, policies and practices, functionalities and procedures, in order to ensure the introduction and implementation of the latest technical and technological solutions for the access to the 112 number. Therefore, cooperation was established between the state body, the Civil Protection Directorate, which is responsible for the operation of 112 number, and the technological profession, the King ICT company. Both parties accepted to participate in this EENA project to make sure that we achieve the set goals in the right way. Thank you. Zoran, please.
Okay. Okay, I will continue. Next slide, please. This is the overall technical architecture. Solution is based on standard technologies that are ubiquitous and already available on both Android and iOS mobile platforms, as well as on laptop computers. Key underlying technology is WebRTC for video, audio, and signaling. And solution is based on EENA long-term definition standards. Caller uses a smartphone or laptop computer to access a well-known website, which should be published as much as 112 number is. So something like SOS HR for Croatia, for example, and opens this site in a standard-based browser, Chrome, Safari, for example. This website is a progressive web application that is possible to install, to be installed on home screen on smartphone, so that any further usage will feel like a native application. Person doesn't need to open a web browser next time. Basic flow of call is that user or place call via SIP, the SIP user agent that is implemented with JavaScript. And the WebRTC makes WebRTC offer with an invitation together with location information. This call is forwarded to, invite message is forwarded to SCRP. SCRP records location information to location information service, and at the same time engages SCRI service to get proper most adequate PSAP or destination to this call based on geography, but it could be some other rules could be implemented in this service. For example, depending of type of emergency service, depending of whether it is a day or night, some PSAPs might not work at night, and etc. And then the SCRP determines right PSAP. It forwards invite message to that PSAP. So PSAP must also implement a SIP server to accept this message. And on in our project on PSAP side, this SIP server is integrated with our solutions, Sphera. And incoming call is presented to in PSAP to operator, similar to phone call in incoming queue. And then operator accept this incoming call. Then message goes back. First, it goes SIP 180 ringing message, and when operator accept, then OK message 200 goes back all the way to caller. And in invite message, there is offer, SDP offer, WebRTC offer from caller, and in OK message from operator, there is an answer to that offer. And then both sides, when answer is returned back to caller, then both sides have information of each other, which codec they support, which IP addresses they can use to reach each other. And after that, media connection is established. And in case of PSAP, that most certainly is via turn server, because the caller and operator is very likely could not connect to each other directly, which is possibility in WebRTC, but when one person is behind symmetrical firewall, then that is not possible. So external, basically firewall proxy server turn is used to proxy datagrams media messages. Next slide, please. Okay, and this is all parts of the systems and communication standards that they use to communicate between each other. Main thing here is that all parts are standardized. most of components of the ESINet uses SIP for communication, and for some specialized purpose, for example, location to service translation is used, or for location services publish and held standard messages. The point is that system could be built using standardized components. So in theory, one organization, one PSAP can can put its architecture using parts from different manufacturer. But more importantly, if parts are standardized, then it is that cooperation between PSAPs and between countries are possible, so that there is no not more islands of technologies, but if everyone uses standard technologies, then everyone is interoperable. And there is another benefit of using a JavaScript SIP client is that it uses WebSockets for communication with SERP. SIP over WebSockets is a standard technology, and most SIP proxies should support it. Benefit that comes out of that is that network architecture is simplified, because SERP could be exposed to external callers the same way classical website is exposed. So it could be behind a reverse proxy using the same technologies that websites use, such as SSL and cryptography, and that simplifies pretty much the architecture. Next slide, please. This is more detailed call sequence, how call is made. On both sides, caller and operator in PSAP uses SIP implementation via JavaScript. Caller makes call first, sends invite message to SRP, holding containing SDP media descriptor and location message. And based on location message, SRP gets appropriate PSAP, and also stores, pushes location to list server. And when SRP determines appropriate PSAP, then it forwards invite message to that PSAP. SIP server on PSAP side accepts invite message and translates it, integrates it with our PSAP solution, Sfera, and present operator with a new incoming call. And at the same time, SIP server returns back 180 ringing message to the caller. So caller is informed that call is placed, and now he's waiting for operator to accept it, to take it. And when operator take this call, then SIP server actually sends invite message to his user agent, and then after that thing flows pretty much standard base. So user agent of operator extracts offer from invite, creates answer via WebRTC engine, and sends back that answer in 200 OK message to the user. And user caller when gets answer message, then both sides have all parts needed to communication, and then he sends back acknowledge, so to acknowledge that everything went good. And after that, media datagrams exchange, actually media stream is established via turn server. Next slide, please. Our testing setup was in 2 counties in Croatia. This is city of Zagreb and Zagreb County. We use SRF uses geoshapes of these counties to determine most appropriate PSAPs. And we have used domain sos-nextgen112.net for testing purposes. And we believe there's some similar URL domain should be used in production, probably sos.hr or sos. And top level domain of the country. Next slide, please. These are a few screenshots from caller side perspective. On first screen, that is presented to caller when he opens the site. He enters his phone number and his name in order to enable PSAP to call back if there will be need. So this in our testing scenario, we did not require a previous registration, but if if organization such as Civil Protectorate in Croatia would not allow anonymous calls, then it is easy to set up registration. For example, caller will enter his phone, click to register, and he will get SMS message back. And when he clicks links in this SMS message, he's registered. That way he's confirm his phone number, and he's identified by this phone number. This phone number and name goes in invite message to PSAP site, so it is presented to PSAP. And next to screenshots are text call and video call. Next slide, please. And this is our application Sphera that is used in PSAPs. In this version, it is integrated with NextGen 112 project. So in both audio, video, and text call, there is a location of caller. Next slide, please. And we have anticipated to show you a short live demo. I don't know, Christina, if it is possible. I would need to present my desktop to show live demo. Is it possible?
You have indeed to share your screen.
Okay.
Okay, Soran, you have now been made a presenter.
Okay.
So you can share your screen now.
Okay. Show my screen. Okay. Do you see my logo on screen?
We're seeing the desktop background.
Beautiful.
Desktop. Can I change this? No. Can I my primary screen? I don't know how can I show screen. Just a second. No.
On the sharing options, you would see a button that is called Show, and then you have a menu where you can see if you want to share your screen or other versions of your screen.
Okay.
Now we can see it.
Just up. Okay, this is okay. This is logon application. I wanted to show entire screen. Just a second. Just a second. Screen. Okay. This is what I wanted to show. I will now ask a colleague that is on other part of town to place calls, so we can show it. Zapravo. Odmah. Just a second. 1 minute that colleague goes outside of his house. He's at home due to COVID situation, and he will go outside of his house in order to get location, because I don't know if he will present location inside house. Here it is. So we will answer the call, and we got the name and his phone number, and we got his location, and also video stream. Can you hear us, Ivica? Yes, we can hear him. Okay, this is in this is a small town the other side of Zagreb County. This is location, and this is from his view from his balcony. Basically, that is basically that we show short demo. Isa, thank you. Bye. Okay. We can also make a back call to caller, not just this one that is called via video next gen, but also any other caller. He receives SMS message, and when he clicks in that message, we can establish video connection. That way, the operator can establish video link. Okay, that was short demo. You can return to presentation last slide.
Okay, I will then share my screen. Okay, do you see my screen?
Yes. Just next slide, please. Okay. So for conclusion, we think we proved that the next-gen standard implementation of next-gen solution is possible to implement without caller side, and underlying technologies are WebRTC, SIP implementation with the JavaScript. There are actually few of them. We used JS SIP, and the progressive web application that is actually basically classical web application, but that can be installed on home screen, and that can have a native app user experience. We use SIP over WebSockets that simplifies network infrastructure and security and so on. We also think that the video stream from incident place is of great value, particularly in certain situations, for example, in ambulance need, or when there is a fire, or when there is a car accident that enables operator and some other personnel in PSAPs to correctly assess situation and to engage appropriate resources. And to conclude all of that, we think that all prerequisites already exist for quite some time now. All mobile platforms has implemented these underlying technologies, and actually there is nothing in a way to implement next-gen solution in production right now, not later. And that was all that we have prepared for presentation. We are open for questions.
Thank you very much for this presentation and the demo. I will now open. I think we have already one question, but I saw it before. I think it was in the chat. Well, so we had one, in case of the media exchange via turn, how is the solution for recording the media? It was made by William Blaine.
Okay, well, that was not part of our project, but of course, for media to record, we must have intermediate server that is actually that receives that takes like back-to-back user agent in SIP that talks media to original caller and to operator on the other side, and to be able to be man in the middle to be able to record media. Other possibility that is not as good is to record media on a client side. That is possible without any service in the middle. That client side, I mean on operator side. And because media is available on operator browser, he can stream that media via WebSockets or something like that back to some local server to record it. So that is basically two options. One easier and less secure, less robust, is to record at the operator's web browser. and the more robust and more complicated is to have a server in the middle that understands media.
Okay, thank you. We have another question. Thank you for the presentation. Are the video calls recorded?
Sorry?
Are the video calls recorded?
No, as I said in the previous answer, that was not part of this project, but in case of implementing this solution in production, that should certainly be part of that project. But it was not part of this project. So we know how to do it, but it was just not enough time to do it in this project.
Okay, I have one. We have two more. How do you guys implement texting? Do you use MSRP or RTT protocols?
Well, we first incarnation was to use message SIP messages. SIP message that is called message. But that has its own problems, mostly when it takes load on infrastructure. And secondly, when caller moves, then we need to record the route. We need to ensure that the caller stays with same operator. That adds to difficult technical complexity. And we change our mind and return to WebRTC all the way. So we use WebRTC data channel. So WebRTC have basically has media streams, audio, video, and video, but also has a data channel. And via data channel, you can exchange whatever you like. So you can use it for for screen sharing, for example, or for text messages and so on. So it doesn't connection is established only once, only one invite and OK message is sent through the system. So after connection is established, no more load to the system is present, and two sides connects directly, actually via turn server, but more or less directly.
Okay, thank you. We have another question. We are running a little bit late. We have here 3 more questions and a raised hand. So the next one is, what is your experience regarding the performance of progressive web apps versus native apps? From
well, performance depends on usage. So in this scenario, all that progressive web app has to do is very, very simple. So so there is we could if we implement this application as a native app, there will be no noticeable for users. The user would not notice any difference. So this is not a video game that you need maximal performance, and all hard stuff is already done by engine, by browser engine. So WebRTC media and everything that needs resources is implemented pretty much optimally via browser engine and implemented very good in our experience. So in this case regarding performance, there is no any difference between native app and this progressive app.
Okay, next question is, what are your European deployment expectations?
Sorry?
What are your European deployment expectations? So I think
maybe Mariam would be better to answer this.
But now the European Commission has formed the working group on implementation or the European Code and the Accessibility Act of the European Union. So the next steps are until I think 2022 that the first of requirements or acts will be done. So it is hard. We are at the beginning, so it is hard to say now at this moment how it will go. But we have in the code some dates, when we have to finish some of our tasks.
Here I may also help a little bit, just as it was said, the implementation of Next Generation 112 is starting now in Europe. So we hope and we are working on it so that it's implemented as fast as possible. And we hope that there will be more implementations in the following months and in next year. Okay, then we have another question. The call control of the call from Sfera to see the call and send it to the agent is done through a proprietary interface.
Sorry, can you repeat?
The call control of the call from Sfera to see the call and send it to the agent, is it done through a proprietary interface?
No, all signalization regarding calls are done via SIP. So a call can propagate, for example, in a SERP server, if he decides via this SRF server that call should go to, for example, some other country or some other PSAP, then it will forward invite message to that some other SERP. Or if it can on PSAP side, there is a SIP server that is a standard SIP server that accepts invite message, so that Sfera can receive this call from some other party, so from SERF that is not done by us, or from some other SIP server. So as long as messages are according to standard and CP standard, then there should be interworking possibility. So no proprietary standard, no proprietary protocols to the edges of Sfera system. internally, this SIP server on PSAP side is connected via some kind of a plugin and driver that talks to Sfera server, a Sfera system. The similar way that we are connecting to classical PBX via CTI, for example. So Sfera uses one driver or plugin to communicate with PBX for the classical telephone calls, and another similar to communicate with the SIP server that receives these SIP calls. So it is not proprietary to the edges of our system.
Okay, we have another question. Which messaging protocol did you use?
Sorry?
Which messaging protocol did you use, or just exchange plain text messages?
Well, we use data channel in WebRTC. So we exchange plain text messages because it is well, we didn't work much on actually which text exchange standard do we use, but it is a channel that we can send and receive bytes, and that bytes can easily be formatted in some more standard way. Should be that standard established for exchanging text messages this way. So there is no actually standard besides WebRTC. It's just bytes exchange. And for video and audio, it is standard. It's WebRTC.
Okay, we have 6 more questions. So we are running a little bit out of time, but if that's okay for the 2 presenters, I will go through them. Do you have time, Zoran and Marian?
I have, I don't know for Marian. He nods, it's okay.
Okay, super. So we have the next one is your slide mentioned the first call taker routing the call to a second call taker. What is the segregation of responsibilities of the first call taker versus final call takers of the PSAP?
In our solution, in 112 call taker can in one PSAP center, all call takers are equal, so to say. So call comes appears in queue that is a common incoming queue for the whole PSAP. And first call taker that is available takes call. And if it is some simple situation, he can manage it alone. Or if he needs some another emergency service, for example, medical care or police or fire brigade, then he forwards the call. He can forward the call as a call to connect in conference call, or he can just forward as a incident via data to some next emergency service. I don't know if that answers the question. That is how it is a job organized in call centers that has Sfera implemented in it.
Okay, we have now a comment, more than a question. It's a comment from Victor Manuel saying comment for the progressive web apps question. It has offline capabilities, can put push notifications, and it is installable in desktop, Android and iOS, but Safari doesn't have push notifications yet.
Yes, of course. That is well. It is it is a work in progress actually. Safari and Apple is little late to this party. Actually, Apple was first with the progressive web application. If you remember, it was the first on iOS. There was a possibility to make some page, save some page to home screen and to launch it without browser Chrome, without edges, like a native app. But progressive web application is much more. It is a philosophy to enable user to have as much a situation allows. So if connection is poor, then he has some functionality, limited, but it is functional. Even if there is no connection with the original site, for example, then SIP implementation is in JavaScript, and it can run offline, not offline entirely, but offline regarding to original site. So if SOS HR, for example, is down for whatever reason, client and but EZNet is online, a client can make call, no problem. So I agree fully with the comment.
Okay, thank you. Next one is, what kind of analytics did you derive from this information?
Which information? Well, we have for civil protectorate in Croatia, there is some set of statistics that that actually is, I believe, is mandatory from European Union.
Yes. Mi se vodimo prema ključnim pokazateljima, key performance indicators from the European Commission.
You can better use my microphone so to avoid because I have a monitor, I have a TV screen connected to my laptop, and the laptop has echo cancellation, but when we switched two laptops, then the problem with echo goes up. So better use here.
There are key performance indicators that are mandatory from European Union, European Commission. So we gather all that necessary data, and of course maybe some more that will help us in our work. So it is hard to mention all of them now, but of course we inform European Commission about this data about key performance indicator every year.
Maybe I could just add that goal of this project was not statistical, so to say. Our goal is to prove that technology is worth it, that we can achieve a next-gen solution with these technologies. and what should be reported and what statistics should be keep and report, that is up to civil protectorate or PSAP authorities. If that answers your question.
I think it's a very complete answer. So we have another one. Is the infrastructure available in a redundant way, so calls are not lost?
Yes, of course. Well, in this project, the goal is not to implement a solution in production. So this was secondary. It was not a primary concern, this availability and such concerns. But in production implementation, of course, everything redundant, and this technology enables it naturally. So if so call routes through the system, if one node is down, other node should take it over. So I think that next gen, one of benefits of next gen architecture is that it enables redundancy and security, so to say, out of the box.
Okay, then we have one more comment from Victor Manuel about the progressive web apps. One code for 3 platforms. It has also service workers that works in the background to bring push notifications from EENA 112 services, for example. Okay.
Well, yes, of course, it is a underlying technology that enables that things. So what will be used in particular installation is up to needs of particular organization where it is installed.
And the last question is, will this solution remain in use in the chosen PSAPs?
No, this is a test, so to say, pilot project, but it is not in production. So it is a proof of concept rather. So next logical step would be to implement some pilot or something like that in real production. So, but it is entirely up to civil protectorate and to make some deal or something like that. I'm just a technical guy.
Okay, so I think we have gone through all the questions. Thank you all. Thank you very much for the participants, for all these very interesting questions. A big thank you to both presenters from the Croatian consortium. And we are really late, so but I think it was worth to take the time to go through all the questions. And I think we can now close the webinar. Thank you again to the Turkish and the Croatian presenters for sharing with us the work that you have done. Congratulations again, because the results are really amazing. And please don't hesitate to contact any of the presenters or myself in case you have any question, comment, or request, or do you want to know more about one thing that we have presented during this webinar. And that's it from my side. Thank you again. Have a good afternoon, and I hope we will speak very soon. Goodbye.
Thank you. Bye bye.
Thank you. Bye.
Bye.